Dear students, today we will discuss on distributed and parallel operating systems. Distributed operating systems. We have seen in the previous video series about the types of the operating system where I have discussed on the distributed operating systems. A simple example is nothing but a internet. So in a distributed operating systems, we see that if this is a main server, it will be associated to the or linked to number of other server or a number of other server in a star form or in a mesh forms. So this is known as a distributions, that a main server is connected to the client. So all these clients are linked to the main server. So this is known as a distributed operating systems. So you see that this is having a dialogue with this one, this is having a dialogue with this server. Like that individual server is distributed. It is not within one server. Each server is separately, but every server is linked to the main server. So this is known as a loosely coupled. Parallel operating system is what? Suppose this is the main CPU, you are having a multiple core, okay? Or we say that this is the operating systems, you are having a number of operating systems. So let us take the window operating system, Ubuntu is there, Linux is there, then you are having a operating systems related to the Apple. So that is, or you are here, let us take that you are having a mobile operating systems, Android is also associated. So this type of operating systems, all this operating system is running parallelly, all these things operating parallelly. So that means under one CPU the entire operating system is linked. So this is known as a parallel, or we say that it is tightly coupled. Another point to see this one is that every operating systems will have its every server which is connected to the client server, this will have its own memory. This will have its own memory because server is having its own primary and secondary memory. So it is having its own memory. So this, particularly the main memory, whatever the server is having, this is not going to shared by the others. This is independent. Every operating system, operating systems server, this is operating systems running in this server, this is operating system running in this server, operating system running in this server, operating system in this operating. So this operating system is managing its resources with this server. So this operating system will not manage the resources of this memory or this memory. But here, whatever memory is there here, this is managed by the entire operating systems which is running in this, in the case of a parallel operating system. So that's why here the sharing of the memory is not exist. Sharing of memory do not exist. Here, yes, you can put it as it's a single wide primary memory. Now, if you try to see, as in the case of internet, all this particular server, what you see across this one, which I put as a client, this is also further distributed to another server. So whatever it may be, but it is spreaded globally. That's why it is, we say that it is spreaded globally. Whereas in the case of parallel operating systems, it is inside one enclosure, because it is everything is within one block. The next is that in this case every operating system is able to run with its own clock. Clock is something like in our human being we are having a heartbeat. So just like in the heartbeat allow us to allow the entire body systems to perform in the same way. In the CPU or in the computer there is a clock that allow the entire CPU to keep on working. So that's why in the case of a distributed operating systems there is no global clock, whereas in this case the global clock, or we can say that global clock is used to control. That is the another thing is that. Now the another point we have to understand that in the distributed operating systems there is a particular delay is existing. That means say that this is communicating with this one, this is communicating with this one. There may be that the request is gone and the response is coming back, just like a dialogue is taking place. Request gone, response back. Here request gone, response back. So all this scenario, it will vary depending upon how the individual the end server is going to respond, or the client is going to respond. So that's why in this case unpredictable communication delay. Whereas in this particular scenario, the interconnections, latency means delay is minimum. That is the another things we have to understand is that. Now, apart from these particular things, let us put this one is that, because normally this is being considered as one of the important questions in the university exams. There are, if suppose if it is asked for the say 6 to 8 marks, how this particular comparison we have to put across. Basically, the distributed operating systems, it is used for the network computer. Network computer means, you see, these are connected in a network. So that's why this is used for a network computers. Whereas this one, where we are using, wherever multi-processing is needed. We have already discussed multi-processing needed means, say that we are given a multiple tasks, MP3 running, MP4 running, web browsings, say at the time MATLAB running, we are running Python, all these things where the single CPU is not capable, the multi-processing will be able to handle. The next point is that in a distributed systems, the communication occurs between multiple computer, whereas in this case how it is within one computer, because every activities is taking place in one computer. Here it is distributed. That is the point. Next we will see that in this case the communications is having a stability in the case of a distributions. That means in the case of a distribution, suppose if this one fails, the other server will take care. So that is the things. And in this case of the parallel computing systems, this is also increase the performance, but there are chances that this may fail, but this will not fail. So it increase stability and share resource. and here increase performance and use for scientific computing. So computing. The disadvantage part in this case is what? If the one distributed server fails, other will take care. So here the breakdown is not complex or much delay. Whereas here in this case, if the breakdown cause entire process to shut, or when I say process, the entire operating system to shut. Whereas in this case, breakdown is not a complex, and it will not much cause a much delay, whereas the other operating systems will work. Whereas in this case, if the breakdown of one operating system is there, other will work, but in this case, if one CPU the CPU fails, the whole things will collapse if it is working under single CPU. Whereas if it is here, since it is distributed, CPU is also distributed, operating system is also distributed, so it is not complex. Whereas there are the chances of the basic complete breakdown happens in the case of a parallel operating systems. Thank you.